I'm David Chandler. I have a bachelor's degree in physics from Harvey Mudd College and a master's in education from Claremont Graduate University and another master's in mathematics from California Polytechnic University. And I've been teaching all those subjects in high school and college level, both mostly here in California, but also overseas and um, quite a few different kinds of schools. In any case, I've been teaching for over 30 years.
Good. What prompted you to take a second look at the events
Yeah.
of 9/11?
The first things I looked at in terms of what happened on 9/11 was looking at how explosive the collapse, the supposed collapses of these buildings were. I'd rather call them destruction of the buildings. That things are being thrown out horizontally very rapidly. And the first thing I did was I just right up on the television screen, I just estimated I took some measurements right on the television screen. I looked up some sizes and distances on the internet, and I did an estimate of how fast some of this stuff was being thrown horizontally. And it was upwards of 60 miles an hour. And that told me something sort of weird is going on. It doesn't look like a building coming down. It's very explosive in the way it's behaving. And that got me hooked into actually starting to look. Along the way, I have a tool that I use in teaching. I had a simple tool at the time called Physics Toolkit, which allowed me to take a video and put a dot on each frame to follow the motion of things. And so you can measure speeds and accelerations, and it'll do the analysis and so forth. And I was using this kind of a tool to actually take measurements so that I could, if you see something, say that looks fast, that's one thing. But if you can actually put these little dots on there and actually take measurements and know how fast are things coming down, how fast are things being thrown. And I just started measuring everything I could about this. I watched these little jets coming out the side, and I estimated these are coming out faster than 100 miles an hour. I've measured several horizontal projectiles of what are clearly massive units of, like the wall units come out like three at a time, three columns with a couple of spandrels. And those are, one of my estimates of that was about 4 tons. Apparently they differ depending on where they came out of the building. But these things are being thrown anywhere from, one of them was 45 all the way up to over 70 miles an hour. The number I got was 78 miles an hour. So something's happening to throw these things horizontally at those kinds of speeds. And when you have something moving at 78 miles an hour and you can tell enough detail to see that it's actually one of those little wall units, so you know how massive it is. And here it is trailing white smoke the whole time. It really is indicative of some kind of explosion. It's not what I would call smoking gun evidence at that stage, but that is very suggestive of an explosion. One of the things that I measured that may have the most traction was the third building that fell was building 7, and it came down very fast. And I'd heard people say, well, it came down at free fall or close to free fall and so forth. So I decided I'd measure it myself, and I did a number of different measurements on that. And in the process, I said, yeah, it's coming down close to free fall, but I noticed that it was actually coming down faster at the beginning and then not so fast later. If you average it all out, it's a little bit less than free fall. But I looked at that section at which it was coming down faster, and I realized that it's actually coming down at free fall for a portion of the way it's coming down. And so it's actually coming down at free fall for over 100 feet, which is astounding because the only way something can collapse at free fall, that's just like taking your car keys out and just dropping them. That's how fast the building came down for over 100 feet. And the only way you can get that is when there's zero resistance. And so what we're looking at is a building just coming straight down, falling right through itself with zero resistance. Buildings don't have zero resistance, which is why you feel comfortable walking into a building. Okay, but what we have here is the building is In order for it to be falling down with zero resistance, it means that resistance had to have been removed by something else. The falling part of the building can't be what's removing things. It can't be what's crushing it or destroying it, because any energy that gets used to do that is less energy to be converted into just the downward motion. You can't, one of the fundamental laws of nature is the conservation of energy. And if you use the energy to go from potential, which is like by being elevated, and you convert it to kinetic energy, then so the energy could be used to make kinetic energy, or it could be used to generate heat, to break up things, pulverize the concrete, and so forth. But you can't use it for all those other things and at the same time have it come down as fast. You have to sort of parcel it out. And so if you use some of it for breaking up the building, there will be less of it to generate downward speed. And so the fact that it's coming down at free fall says all of the energy is being used to just make it go straight down, which means it's coming down through itself and not breaking up the building as it goes. Something else has to be clearing the way. And that is smoking gun evidence to me. I think that's one of the primary pieces of evidence that these buildings really were demolished. They weren't just accidents that happened. And they couldn't be. It just doesn't work out that way. I did measurements of the other buildings as well. I've worked on all three of them at one time or another. The North Tower is interesting in that the top section seems to come straight down. It actually is tilting a little bit, but it's not a whole lot. The South Tower pretty much falls off. I mean, it tips way over. But the North Tower, it starts out coming straight down into the building. It does not come down at free fall. It's about 2/3 of free fall. And I figured that out. But then I started playing with that, and I said, okay, if it's coming down at 2/3 of free fall, what does that really mean? And so I started doing my analysis. You do a little something called a free body diagram. You do a little block, and you put arrows on there representing the forces. And there's basically two forces at work. There's a downward force due to gravity, and then there's the upward force due to the resistance of all this building down below, all right? Okay, and then what my evidence showed was this block accelerates straight down. Or it's picking up speed downward continually. It doesn't slow down, it just continues to gain speed. That's called downward acceleration. And one of the basic laws of Newton's second law of motion is that the acceleration is going to be in the direction of the net force. So the net force has to be downward. Well, here's your two forces. To get a downward net force, it means the upward force must be less than the downward force. Otherwise, it would have a net force that's upward. So the fact that it's accelerating downward the entire time means the upward force is less than the weight of the upper block. And if you turn it around, it means the force of interaction between the two blocks is less than the weight of the upper block. And if you think about it, what that means is this upper block is exerting less force on the building than if it were simply sitting there. So it's actually falling with less impact than if it were just sitting at rest on top of this lower structure. Now that's very counterintuitive. And the reason it's so counterintuitive is like you take a hammer and it hits a nail, you expect it to exert a greater force than just the weight of the hammerhead. But if you have a hammer hitting a nail and it's in a piece of styrofoam, there's nothing to stop it. There's really no force of interaction. It just accelerates right through that. That's what's happening here. The top section is not crushing the bottom section of the building, or it would meet resistance. It's just falling into the rubble, which has already been created by the blast, which has pushed this other stuff out of the way.
And it would slow down too, right?
Yeah. Yeah, if you have this block continuing to accelerate, it's telling you that it never actually impacts anything. When a hammer hits a nail, the hammerhead slows down. When a football player goes to tackle another football player, they collide, and the one that's running gets slowed down by the one he's running into. So whenever you have these interactions, they work both ways. And the same thing here is the top section, if it actually collides and actually exerts a force on the lower section, it's going to experience the countervailing force that would actually slow it down in the process.
One would expect a jolt.
Yeah. Tony Zambodi is another engineer. I believe he's going to get interviewed. I shouldn't say that. Tony Zambodi is another engineer who's done another analysis very similar to what I have. And he basically expresses it as you're looking for a jolt. That this thing, if it actually comes down and hits, you should be able to see the point at which they actually impact, because it would actually slow down the motion of the falling block. But the data, by actually looking at, with this little tool that I have, where we're measuring the motion of the building, it never slows down. It accelerates the entire time. And that was what was extremely significant. So I published a paper about that. It's in the Journal of 9/11 Studies. The reason I published it in Journal of 9/11 Studies is I submitted it to 2 other journals, and all of these topics regarding to 9/11 have become so stigmatized that mainline journals are very reluctant to even go there. And it's good science. It's been peer reviewed by other physicists and engineers. And if the listeners here are competent, they can read the paper and judge for themselves. But it is published to where you can actually look at the arguments, and it's very persuasive if people who are involved in physics look at this argument. When I was looking at the North Tower, I basically measured the roof line and found that it accelerates downward. It does not come down at free fall like it did in Building 7. It comes down about 2/3 at the rate of free fall. And so it is meeting some resistance. But then I took it further, and I took the block and I did a little what's called a free body diagram to try to analyze what are the forces that would be needed to allow this thing to come down at 2/3 of the acceleration of gravity. And basically, what you do is a little independent little blocks called a free body diagram, and then you put your little arrows on there indicating your forces. And there's 2 forces at work. There's gravity, which is downward, and the lower structure produces an upward force, which would be supporting it. And so there's your 2 forces, and you combine them to get a net force. And if the upward force is greater, the net force is going to be greater. If the downward force is greater, the net force is downward. Well, when I actually measured the motion of that top block, it's coming down with a downward acceleration. In fact, it's a uniform downward acceleration. It's 2/3 of gravity, but it's accelerating downward. It's continually picking up downward speed the entire time. The only way that can happen is if the net force is downward. So here's our 2 forces. Gravity is greater than the resistance. Okay? So this force, the force of the lower section of the building pushing up on that top block, is actually less than the weight of the top block, which is very counterintuitive. Now, let's turn that around. This is the force of interaction between the 2 sections, and it works both ways. So the upper block, in other words, is pushing down on the lower block with the same force the lower block's pushing up on the upper one, right? And so if the force that's upward is only 1/3 of the weight of the upper block, it means here's this upper block falling through the lower, stronger, undamaged building structure below it, and it's only exerting 1/3 of its weight. This structure was capable of holding 3 to 5 times the weight, and here it is falling through it with a resistance of only 1/3 of its weight. Roughly 90% of the resistance has been removed, and what's happening is the top section is not crushing down the lower section like a pile driver, which is the picture that NIST basically is painting. It's actually falling into material that's already been pulverized, that's offering very little resistance. It's just coming down through pre-pulverized material. Another way to see this is if let's assume that these things did crush each other. Forget the evidence. The evidence is it didn't. But say they did. The top section pushing on the bottom section, it's going to meet equal forces as it goes. Both sections are going to be demolished at the same rate. So by the time you've crushed up 15 stories below it, the top 15 stories are also going to be crushed. And so there's nothing left now to crush the rest of the building. So there's so many paradoxes here. A little tiny chunk of the building can't possibly fall and crush the entire structure below it. One of the things about the lower section of the building that a lot of people don't understand, and the reason they don't understand it is the early theories that were circulated in the media were misleading. They talked about pancaking collapse and so forth. NIST rejected that theory. Pancaking collapse doesn't work because what you have in the case of the towers is an inner core structure of 47 core columns, and they're very strongly cross-braced. This is like a building within a building. If all the floors came pancaking down, you'd have this entire core structure still standing there. And so they had to somehow come up with a theory that would get rid of the core structure. Therefore, they said there you have this pile driver effect. So what I've basically shown is the pile driver effect doesn't work. There's no pile driver. Or the pile driver would destroy itself before it got very far. And if you actually look at the way it's moving, it's not exerting enough force to break up the building in the first place. So the actual data says it's not even acting like a pile driver. And then if we say, well, let's pretend that it did, it would only get about 15 floors, worst case scenario. So what we're looking at is the core structure of the building had to have been destroyed by other means. So any honest investigator would be looking at this and looking for explosives and so forth. The NIST investigation didn't go there. They just would not look for explosives. There have been explosives found in the dust and the debris, but this has been the work of independent researchers, not NIST.
Good. Now, in this second redo, you didn't talk about the hammer and the styrofoam.
That gets sort of, okay.
You don't have to, but I wanted,
Okay.
if you wanted to, you could pick it up and we could.
All right, well, I'll give a little thing you can clip it in somewhere. Sort of an analogy of the way this top section, right, you can figure it out before it goes in. One analogy is if you take a hammer and you hit a nail. Have you ever noticed that when you hit a nail, the hammer, when it's exerting a force on the nail is exerting a force on the hammer and it slows it down. In fact, it brings it to a stop, which is usually why you have to hit the nail repeatedly, because you keep hitting the nail and the nail keeps bringing the hammer to a stop, and then you got to do it again, right? So that's an example of how these opposite forces are constantly acting. And so if you had the top section acting like a pile driver or acting like a hammerhead, if in fact it actually hit and made an impact, it was effectively crushing anything, pushing hard on this core structure below it, the core structure is going to push back equally hard. And that's what's going to cause the top section of the building to slow down. But the fact that it's constantly accelerating downward is evidence that it didn't slow down. It never hit anything. It's falling through rubble. It's not actually hitting and engaging with the structure below it in any way that could demolish it.
The 2x4 turned into styrofoam.
Okay. The only way that you can take a nail and hit it with a hammer and not have this kind of a opposite kind of a force is if you have no resistance. So say that instead of trying to pound a nail into a board, you just stick it into a piece of styrofoam. Then you can take your hammer and you can just push, just drive it into the styrofoam, and there's very little force, and there's no force to really slow down there is a tiny force back, but it's not enough to really slow down the hammerhead, because the hammerhead just by falling is going to be picking up speed as it comes down, independent of how you're pushing it, right? But so if you basically push a nail through something where it offers no resistance, then yeah, it can accelerate the whole way. And that's what we see happening in the case of the North Tower. So this section is not behaving like a pile driver or a hammer hitting a nail. It's acting like something that's falling through a bunch of material that's not offering any kind of significant resistance as it falls. And therefore, that cannot be what is shredding and throwing all this stuff out. You just look at if you just simply look at the, the collapse of the towers. I choke every time I say collapse. It doesn't look like a collapse. It's like a huge mushrooming, billowing kind of an event. That whole thing looks nothing like a building falling down. It's a building being blown up. And it's being blown up progressively from the top down. That's what the physics shows.
Okay. How about the South Tower? What have you learned there?
The South Tower was a little bit more complicated to analyze because what you have is it got hit lower, and that the break point is lower in the building, and the whole top section, it starts to come down and then tips, and then as it's tipping, it moves into the debris cloud. And there's some people who talk about how it sort of tips part way and then somehow magically it quits tipping and goes straight down. I'm not quite sure about that, but there's some part of it at least that's continuing to tumble to the side. And so, hey, if the top section that would be your pile driver falls off the building, what's collapsing the rest of the building? And that's one thing I found by looking at that. The other thing I just did is I just looked at the videos of the South Tower a lot, and I started seeing so many anomalies. I saw projectiles being thrown out, and then the projectile itself would explode. And so I have a video I produced called Exploding Projectiles, and there's one that you can actually see. Here is the projectile coming out. It splits in half, and then it goes for another couple of frames, and each of those halves split in half again. So you have a 4-part breakup of this chunk of material. There's another chunk that's being thrown sideways, and it's trailing a very noticeable white trail of smoke. And the reason, you say, well, if something is moving, maybe there's a lot of dust and stuff sort of following it in the wake. That's one possibility, okay? But this thing went sideways, and then it went through a right angle turn and went straight down. It stopped moving sideways and it started moving down. There had to have been some kind of an interaction at that point to make it change direction, because it had momentum sideways. The momentum just went away. Momentum doesn't just go away. It is given to something else. So whether I sort of loosely called it a rocket, it's not really a rocket effect at all. I've actually done some later study on this, and what it seems that it's happening is it's an assembly of some kind that then breaks apart. So part of it's being thrown off, and as it throws part of it off, that takes the momentum and the other part drops. So what we're actually seeing is here it's going, and then it turns and goes straight down. And the white cloud follows it. So the white cloud is not dust sort of following along, getting entrained in the wake of this thing. It's actually stuff coming off the surface of this. One of the things that happens when you have to go to a specific kind of explosive or incendiary, it can be used both ways, but thermite or nanothermite, one of the byproducts is aluminum oxide, which comes off as a white smoke. And so this has a lot of similarity to what you'd expect if you see the smoldering effects of some of this incendiary material smoldering away and giving off this aluminum oxide smoke as it goes. The fact that it does a right angle turn is very odd. The other thing is, if you start looking at it from different angles, there's lots of puffs of smoke being ejected sideways out of the building, and some people say, oh, well, that's just air pressure as you're compressing it and so forth. Well, in the case of the South Tower, you can see these jets of black smoke being ejected from many locations on many different floors above the level of the impact. So here's the block of material that's falling, and within that falling block, you have a lot of these little squibs, they call them, coming out all at the same time. There's just an endless number of things, there's lots and lots of detail that just don't add up. There's another example, there are some of the downward projectiles. I haven't
Talk
actually.
about the speed of those squibs before we get off of. You didn't mention.
Another one of my little analysis videos that I did was actually prompted by Graham McQueen, who noticed that this was in the North Tower, and he noticed there's a whole bunch of these squibs or puffs that are coming out the side of the building. And naysayers tend to say, well, that's just air being blown out the windows because you have like an accordion effect. It's being compressed. Well, it's going on at a lot of different levels at the same time is one thing. And if you're compressing it out here, if you're blowing out the windows down here, how are you getting the air pressure? I mean, it doesn't really work to say it's just air pressure. But in any case, what he found was puffs coming right out of the corner of the building where it's solid. You don't have any windows there. And he found this puff that comes, boom, right out of the corner. So what I did was I took what was going on higher in the building. It's actually in a different video, but it's along the same corner of the building. And high in the building, I found a puff that also came right out of the corner. And so I just followed this thing frame by frame, and once it come out the corner, and then a few frames later, the building came down, but there's a column that's remaining, like a straggler, just sticking up there. And I noticed by going back and forth with that, the top of this straggler column is exactly where that puff came out, as though this were something that cut off the column at that point. And they have things called cutter charges that could slice the column. And so here's this column just sort of swaying out there, but it's being supported at the bottom. And then all of a sudden, boom, it just drops in complete free fall all of a sudden. So what I did, I got curious, like what's going on at the other end of that column? Like could we find something that happened at the bottom to let this thing dive into free fall? And so I took the video I was using and the video that Graham McQueen was using, and I found an event that was visible in both to be able to completely synchronize them. And then I found the time that the free fall for this column began. And guess what? At the very instant that that free fall begins is when Graham's lower puff came out. So what we're seeing is we're seeing a puff cutting off the top of the column, and then there's a puff that cuts off the bottom of the column and allows this thing to fall. So the argument that these puffs we see coming out are nothing more than just air blowing out windows is not true, because here is an example at least one where we can identify the top thing is acting like a cutter charge to cut off the top of this column, and here's another one at the bottom, and when that, as soon as that comes out, the whole thing drops. So one of the main columns in the corner of the building, they specifically apparently had charges on those corner columns. The corner columns are what sort of stitched the walls together, and you need to somehow break apart those corners to make the walls become unstable. Otherwise, you have an angle there, and it's nice and strong. So they somehow had to break the corner columns of the walls, and apparently that's what we're seeing happen there.
Fascinating.
I don't really have a sense of necessarily where all this is going. If you look at the Kennedy assassination, it's gone on for years and years, and nothing's happened. And who knows? That could happen again with this. It's very clear that somebody's trying to bury all of this. They're trying to discredit any investigation into 9/11. And I don't necessarily know whether this is going to break open in public consciousness or not. All I can do is what I can do. So my part is just to look as carefully as I can and make as public as I can the kind of things I find out. And Gandhi there's a quote from Gandhi that says, what you do will be insignificant, but it's very important that you do it. And that's sort of my guide in all of this. So I don't know where this is all necessarily going to go. I would like to see a real investigation. I'd like to see people on the inside who really know what happened. I'd like to see some of those come out. There's some very good scientists, I'm sure, at NIST. and their life's work is getting distorted and used for political purposes. We saw that happening a lot under the Bush administration, where you had the, you probably don't want to go there. Under the Bush administration, the whole thing, Bush science, where they went through and edited out the results of various scientific research, and that was going on here too. So, anyway.
And why did you sign the petition for AE 911 Truth, or Architects and Engineers for Truth?
Well, I was, I signed the AE 911 Truth petition very early on, and it was that finally here's a group of people that hopefully to give more credibility to the movement, that some people who actually can look at this with some background and to understand what they're looking at. And I think it's important for the general public to realize that people with scientific and engineering background and experience are not just buying what the media says, but are actually looking at it, and what they see is very definite evidence of explosive demolition, as opposed to just some kind of a natural catastrophe. Natural to the point of after the planes crashed, it's just a natural catastrophe, the buildings came down. It doesn't work that way. The buildings don't fall down, they should not have fallen down. So it's an important thing to have people who understand those issues speak out on the subject.